Good evening, students. So, good evening, Jayashri, Disha, Mirnalini, Nitish.
Good evening, sir.
Good evening, Ma.
Good evening, sir.
Good
Good
evening.
evening, sir.
Good evening, Shruti. Yeah. So, we'll
Good
just.
evening.
Good evening, Soumya. Good evening. So, we'll just get started in a minute, okay?
Yes, sir.
So, students, is the screen visible? So, is the screen visible to you?
Yes, sir.
Okay. So, there's no problem in the voice, also, I guess. Okay. So, yesterday we have seen. Sorry. So, yesterday I've seen till this sum, okay? So before we move on to the next topic, okay, we'll see some of the NEET and JEE questions, okay? Yeah, so previous are NEET, JEE and AAPMT questions with regard to average speed, okay, and average velocity, okay? So this one is a NEET question, okay, asked in the year 2017. Is the question visible to you?
Yes, sir.
Okay, so yeah, the question has given us Preeti reached the metro station, found that the escalator was not working. Okay. She walked up the stationary escalator. What do you mean by stationary? She walked up the stationary escalator. That is the rest. No, that is the escalator is not working. Okay. So she walked up the stationary escalator in time t1. Okay. On the other days, if she remains stationary on the moving escalator. So now the stationary, regularly the escalator will be moving. Okay. So that then the escalator takes her up at time t2. Okay. They're asking what is the time taken by her to walk up on the moving escalator will be. Okay. So what they have given is, so escalators, okay, they are like moving stairs. Okay. So Preeti reached the metro station. Okay. She found out the escalator is not working. So let's say this is Preeti. Okay. Then she walked up on the escalator as like normal stairs. Okay. And she reached the floor. Okay. And from here to here, the motion of Preeti from here, okay, to here to the floor, it has taken her time t1 to reach here. Okay. And the second part of the question, they're saying on other days, okay, on other days, on normal days, the escalator would be working. Okay. So the escalator will take her up. No, it will take her up, okay, to this floor, and she just have to stand here. She doesn't have to move. Okay. So when escalator was working and Preeti, is boarding on the escalator, okay, she's not moving. The escalator takes her up here onto the floor, and for this motion, the time taken is T2 they have given. Okay, now what they are asking is the time taken by her to walk up on the moving escalator will be. For instance, let's say the escalator is working. Okay, the escalator is working normally, and as kids we used to do that. No, we used to do that in railway stations, we used to do that in malls. When there is an escalator, like some kids, what will they do? So they will hop on the escalator. Okay, and the escalator will be moving, and they'll also will hop on each stairs, right? So they'll hop on each stairs. Okay, so that's what Preeti does. Okay, so escalator was moving and she also moves. Okay, she also moving up the stairs, she also does that. Okay, and what is the time taken for this motion, they're asking. Are you clear with the question? This one is given, the first situation till here. The second situation is this. Okay, that is also given. They're asking about the third motion, that is the escalator is also moving and Preeti is also moving towards the floor. Okay, so you understand this question? They're asking the time taken for this motion. Yeah, so is the question clear to you all?
Yes, sir.
Okay, so what is common between these three motions? The first motion is only Preeti is moving. The second motion, escalator is moving. Okay, Preeti is not moving here. The third situation, Preeti is also moving and escalator is also moving. Okay, so what is common between these three situations? The first, the second, and third. What is common? Can you think of anything that is common when comparing the first, second, and third situations? What is common between them? The distance is common, no? If Preeti is moving and the escalator is not moving, means it is the same distance from the ground floor maybe to the first floor. Okay, so this distance is equal to this distance also, even this distance also equal. Am I right?
Yes, sir.
Yeah, so in all these three situations the distance is same. Okay, so I'm going to name this common distance as D. Okay, so they're asking what is the time taken by her to walk up on the moving escalator will be, that is this one. Okay, so to find time, taken, we can you can find it in terms of velocity. Let's say, so for this there will be a velocity, no, for this one, or else I can, just a moment. So for the first situation, that is, excuse me, a student is coming, I guess. Welcome, Vishwa. So for the first situation, that is only Preeti is moving. Okay, and the escalator is not moving. Okay, it's not working. Okay, so for this the time taken is T1, that is given the question. So I'm going to, for this situation, I'm going to name the velocity, the speed of, that is the velocity of Preeti, because only Preeti is moving. Velocity of Preeti is equal to V1. Okay, the second situation, on the other days, the escalator is moving, she is stationary, that is Preeti is stationary. So okay, so she is stationary, and the velocity of escalator, I'm naming it as V2. The time taken is T2, that is given in the question. Okay, so in the third situation, what they have said, that is escalator is also moving. Okay, Preeti is also moving. So just tell me this velocity. Okay, just tell me in the common sense, that is Preeti reaches here. Okay, in all these situations, Preeti reaches here to the floor. Compare this first situation, the third situation. This is third situation, this is the first situation. Okay, here only Preeti is moving. Here the escalator takes her up, and also Preeti is also moving. So in which situation Preeti, Preeti reaches this floor quickly? In which situation? Comparably between 1 and 3. Yes? So you understand my question? See, I have named this, Preeti is moving here, the escalator is stationary, okay? So I have named this velocity of Preeti as V1, okay? And the third situation, even Preeti is moving and escalator is also moving, okay? So compare this first situation with the third situation. So when only Preeti is moving, okay, she reaches here, and in both situations, the Preeti reaches here to the floor. So that's what the question is all about. So when comparing first situation and third situation, in which situation Preeti reaches the floor quickly? Come on, guys, you can. Yeah,
Third one,
Middle,
sir.
third
so,
one.
third,
Third one. Okay, very good. Because the velocity will be higher than just the velocity of Preeti, right? Because velocity of escalator is also involved, right? Okay. Likewise, compare the second situation and third situation. The velocity of escalator, okay, velocity of escalator, that is only the velocity, that is the escalator is only moving. Preeti is just standing stationary on that escalator, and she reaches here. And the third situation, escalator is working and Preeti is also moving. So in which situation Preeti reaches the floor quickly, whether it is second or third? Comparably third, because this involves only the velocity of escalator, and here velocity of Preeti is also involved and velocity of escalator is involved. Am I right? So to find out this velocity, that is Preeti reaching here, okay, I'm going to name this time as t, the time taken for Preeti to reach in this third situation, time taken for Preeti to reach from the ground floor to the first floor, let's say this t. And to find the velocity of this situation, it's nothing but this. I'm going to take it as v. Okay, v is equal to velocity of Preeti plus velocity of escalator. Am I right or not? Because this situation involves the velocity of Preeti and also velocity of escalator. Whereas in the first situation, it involves only the velocity of Preeti. The second situation, it only involves the velocity of escalator. You get my point? Are you clear?
Yes, sir.
Okay, so it comes as v is equal to, what is velocity of Preeti? V1. V is equal to V1 plus velocity of escalator is V2. V is equal to V1 plus V2. Okay, velocity is equal to velocity of Preeti, that is V1 plus velocity of escalator. So what is this V? This V is nothing but the velocity of this third situation. Okay, where Preeti also moves and escalator is also working. Okay, so I'm going to the next slide. So we have found out V is equal to V1 plus V2. V is nothing but velocity, right? Velocity means what? Speed. Speed is equal to what? Distance by time. So substitute this formula in this relation. So what is V? V is nothing but what? Distance that we have seen here. The commonly in these three situations, the distance is only d. Okay. So I'm going to write it as in terms of v. Okay, I'm writing this relation here, d by t. Here the time taken is what? For this situation, third situation is t. And for the first situation is what? T1. That is, distance is common, d by t1. Plus, similarly, for the second situation, that is velocity of escalator situation, that is d is common, the time taken is t2. Okay, so d by t2. So you're getting this or not? You're clear
Yes,
till now?
sir.
Yes, okay. So now what we can do? So here d is common, no? So take d outside, okay? D by t is equal to, take d outside, that is 1 by t1 plus 1 by t2. So strike out these two d's, okay? So what we will have, 1 by t is equal
T1
to,
T2 by T2 plus T1, sir.
very good, very good. So well, what is the option that? That
B.
is B option. Very good. So 1 by t is equal to, here I can cross multiply, right? That is t2 plus t1 divided by t1 t2. So after that we can reciprocate this t to the numerator. So when we do, this comes to the top. So t is equal to t1 t2 divided by t2 plus t1. Okay. This is the time taken by her to walk on the moving escalator. Okay. So clear?
Yes, sir.
Yes.
Okay, so we'll go to the next question. So is the question visible? It was
Yes, sir.
asked, yeah, it was asked in JEE also, main. So it's just a simple question. A particle covers half of its total distance with speed v1 and the rest half of the distance with speed v2. So what is the average speed during the complete journey? Okay, what is the average speed during the complete journey? So what they are saying, there is a distance, and one half of the distance, first half of the distance, a particle covers half of its total distance at speed v1. First half of the distance covered by the speed v1, okay, and another half of the distance, rest half of the distance with speed v2. Okay, they're asking what is the average speed. Okay, so just take this down as a definition. Okay, no, not like a definition. Yeah, it is a, it is a cue for you to solve this problem. Okay, so just write like a note, a distance, a distance. Okay, just make a note under average speed. Okay, a distance covered by two different speeds or velocity. Okay, two different speeds or velocity. Just make a note of this statement, a distance covered by two different speeds or velocity. Okay, so while you're copying this sum, okay, just write this note as a statement as a distance covered by two different speeds or velocity. Okay, right. So what we are doing here is they are asking what is the average speed. So what is the average speed formula? Anyone? Come on quickly. We have some most
Total
yeah,
by total time.
yeah,
Total
total.
distance.
Very good.
Total
Total
time.
distance by total time. Okay, total distance by total time. What is the total distance here? This is the total distance. That is, they have given the distance. Okay, this is a total distance. Okay, so I'm naming this total distance as S. Okay, so the total distance is equal to what? S. Okay, and they're asking total time taken, total distance by total time. Okay, but here time is like, this is covered, this half of the distance is covered by one speed and this half of the distance is covered by another speed, and to cover this half distance there will be a time taken, no? To cover this half distance with the speed v1 there will be a time taken, so I'm going to name it as t1. You understand that? Similarly, to cover distance, another half of the distance, the rest of the distance from here to here, okay, to cover that there will be a time taken for that, to cover that half, this half distance. Okay, so to cover that half of the distance there will be a time taken, so I'm naming it as t2. So then what will be a total time taken? t1 plus t2. You get my point? So average speed is nothing but s by t1 plus t2. You are clear till this?
Yes, sir.
Okay, so here we have to find t1. First find t1. To find t1, what is t1? The same formula, that is what? Speed is equal to distance by time. I'm just talking about this part only. Okay. So here, what is the speed? Speed is nothing but v1. Distance is what? First half of the distance. This is the total distance, yes. So this is going to be the half distance. So half distance is nothing but s by 2, right? So s by 2 divided by t1. Okay. S by 2 divided by t1. So what will happen? So this goes here, velocity comes here. So t1 is equal to s by 2 by v1. This is v1, right? Yeah. So which it can be written as like this, no? We can multiply these two since it is a denominator. So s by 2 v1. Are you clear with this?
Yes, sir.
Okay. So we can write it as s divided by t1 is what? S by 2 v1 plus what is going to be t2? Come on, you can solve this problem. What is t2? You can find t2 by yourself, no? Just calculate. Speed is equal to what? Distance by time. Just calculate for this one. Between the distance here to here. What is the distance? Half distance only, no? Here also. So what will happen? Speed is
Sir,
equal
S
to...
by 2v2.
Very good. S by 2 v2. Okay. So likewise, here speed is nothing but v2 is equal distance is s by 2 divided by t2. Okay. So this goes here, this comes here. So s by 2 v2 is equal to t2. Okay. So this is what it is all about. So I think I have another slide. Okay, yeah. So s by s into 2v1 plus s by 2v2. S is common. We can take it outside. So s by s into 1 by 2v1 plus 1 by 2v2. Right? This s and this s can be cancelled. So cross multiply it. What happens? 2v2 plus 2v1 divided by this thing 4 into v1 v2. In denominator, in the numerator there is 1. So take it to the numerator, that is 4 v1 v2 divided by 2 v2 plus 2 v1. Take 2 commonly outside, that is 4 v1 v2 divided by 2 into v1 plus v2, right? This can be cancelled. So this is the final answer, 2 v1 v2 divided by v1 plus v2. You understand this? Which is the option? B. Very good, Minalini. B is the correct answer. So you guys getting it? Is everyone clear with this question?
Yes, sir.
Okay. So we'll go to the next sum. It is a similar question. Okay. So they're saying it was asked in the year 2007. Okay. It's kind of mains question. Okay. A car moves from X to Y with uniform speed VU and returns to Y. Actually, it is given, it is wrong. Okay. It is returns to X actually. Okay. Returns to X with uniform speed VD. The average speed for this round trip is. So what happens? A car moves from this, let us say this is X to Y. Okay. With speed VU and returns to from Y to X. Okay. Okay. The speed VD. The average speed they are asking. Here, the one such difference, one difference is nothing. That is, the major difference is they have given a total distance. They have given a total distance. That is, they have given a total distance, and first of the distance by one speed, and another part of the distance, half of the distance by another speed. Here, there are two distances. That is, x to y is a distance s, and y to x is a distance s. So average speed is total distance. Total distance is nothing but s plus s. It's nothing but 2s. That is total distance. Okay. And the total time taken. So from x to y there will be a time taken. So I'm going to name it as t1. and from y to x there will be a time taken, so I'm going to name it as t2. You can solve this by yourself. So average speed is nothing but total distance. Total distance is nothing but s plus s, okay, divided by here, that is x to y, that is t1, total time taken t1, plus here y to x, that is t2, that is 2s divided by t1 plus t2, 2s divided by t1 plus t2. So what is t1? Come on, you can do this quickly so that we can go to the another topics and all. So what is t1? T1 is equal to what? Time is equal to distance by speed, right? Speed is equal to distance by time. Time is equal to distance by speed. What is distance here? Till here. Distance is s. Divided by what is the speed here? vu. Okay, so what is t2? T2 is equal to what? Y to x. Distance by speed. So what is the distance here? Yes.
S by VD.
Yeah, s by vd. Very good. So t1 plus t2 is equal to, just make a note here also, okay, two distances for this question, okay, two distances covered by two equal distances, sorry, two equal distances covered by two speeds or velocities. Two equal distances covered by two speeds or velocities, okay. So now so what is just substitute t1 and t2 here. So 2s divided by t1 is s by vu plus t2 is s by vd, okay. Take s commonly outside, 2s into s into 1 by vu plus 1 by vd. S will be get cancelled. Do the cross multiplication and tell the answer.
For option D.
Option D, very good. Option D, very good. So you just made a note of this, no? That is two equal distances covered by two speeds or two velocities, okay. So we'll move to the next similar question. We'll come back to this one later, okay. So yeah, just they have given a distance. This question will trick you, okay. This is asked in the year 1991. So this question will trick you. They have given a distance. As far as possible, we have we have just assumed a distance, yes, 2s, like that. Here they have given a distance, that is 200 meters, okay, and they are saying first half of the distance with speed 40 kilometers and second half of this distance with speed v, and they are given a average speed value also. They are asking what is the value of v. So here, so which one is this? Excuse me, ma, just a moment. Welcome, Xavier. Welcome to the class. Yeah. So here, sorry. So what is the first note you made for this question? You have made one note, no? Can anyone tell me? I've asked you to make a note of one statement. Okay. Could you just read it? Read it. Anyone? Okay. I'll say it. A distance covered by. A distance covered by. I think you should be interactive, ma. A distance covered by two different speeds, right? And for this, two equal distance covered by two equal distances covered by two different speeds or velocities, right? Do you guys follow? So here in this sum, they are given a distance. They are saying first of the distance at 40 kilometer per hour and the second half of the distance v. Okay, which of the following note does it belong to? Whether it belongs to this statement or whether it belongs to this statement. A distance covered by two different speeds is this statement for this question, and here two equal distance covered by two different speeds. Okay, that is for this question. So you just, this is a question. They are given a distance. First half of the distance is covered by 40 km per hour. Second half of the distance is covered by v. So what is the note? That is, what is the statement for this question? Are you guys with me?
Yes, sir.
Yeah, tell me, ma. Just try it, no problem. Two equal, sorry, I just missed it. Two equal distances. Two equal distances covered by two different speeds. Okay, either way. Okay, so it so as you said, it is under the two statements. Okay, so this question is similar to this question and this question also. Okay, so you can straight away write like this, that is average speed is equal to 2v1 v2 divided by v1 plus v2. You get my point or not? For this question you don't have to average speed is equal to total distance, right? Total distance by total time taken. So total distance is nothing but 200 meters. Since the kilometer is in meter, that is the since the speed is in kilometer, you have to convert it into meter format and you have to do the calculation. But simply, because they have given average speed formula, that is average speed value here, average speed formula. The average speed formula is nothing but 2v1 v2 divided by v1 plus v2 for sums like this: two equal distance covered by two different speeds, a distance covered by two different speeds. Okay, you understand? So if it satisfies any of those two statements, you can straight away write as average speed formula as 2v1 v2 divided by v1 plus v2. So here v1 is nothing but what? 40. Here v1. v2 is v. v2 is nothing but what? v. And you know what is the average speed value they have given? Average speed is nothing but 48 kilometers. So substitute all this. Average speed is 48 kilometer per hour. 2 into v1 is what? 40. v2 is just v divided by v1 is 40 plus what is v2? v. Okay, now we have to find the value of v. Okay, so what happens here? 48 is equal to 80 v. 2 into 40, 80 divided by 40 plus v. Now simplify and tell me the answer. Find the value of v by yourself. You can do this.
Sir, option B, 60 kilometer per hour.
Option D, 60 kilometer per
B.
B. Okay, option B. Okay, so what about others? Is she right? Your good name?
Disha, sir.
Disha, very good. So is Disha right? Okay, thank you, Mrinalini. Okay, so option B is the correct answer. Is anybody getting it? Is everybody getting it? Disha,
Yes.
yeah. Okay,
Yes, sir.
thank you. So we'll move on to the next sum. Here they have given, okay, a bus traveling, first one, they have given a distance here. Okay, there are three equal distances covered by three different speeds. This was asked in 1991. Speeds or velocities. Okay. Three equal distances covered by three different speeds or velocity. Okay, it is in that format. So they are given a distance. I'm taking the distance as yes. Okay, they are saying one third of the distance. One third of the distance is covered at the speed of 10 kilometer per hour. Okay, and another one third of the distance is what? It is covered at the speed of 20 kilometer per hour. Okay, the last one third of the distance is 60 kilometer per hour. You getting? So this is what given the question. They're asking what is the average speed of the bus. And this is a easy question only. You can directly, you know the average speed formula, that is total distance traveled divided by total time taken. So for this one third of the distance, I'm going to have it as T1, and for this one third of the distance, I'm going to have it as T2, and for the last one third of the distance, I'm going to have it as T3. Okay. So what is the total distance here? Total distance is this one. Yes, right? So total distance is yes divided by T1 plus T2 plus T3. So what is T1? What is T1, ma? What about Disha?
S by V1.
S by V1. They have said one third of the distance. So if I'm just calculating this one to find out, I have to calculate velocity for the velocity and distance for this only. Okay. So just find out for this. That is speed is equal to distance by time. Very good, Mirnalini. Yeah. Speed is equal to what? Distance by time. Distance is what? Here. One third of the distance. That is S by 3. Right, Disha?
Yes, sir.
Yeah, one third of the distance. That is S by 3 by T1 is equal to, what is the speed here? 10 kilometer per hour. Now take this T here and take this to the denominator. That is what happens. T1 is equal to S by 3 divided by 10. So which in turn becomes T1 is equal to S by 30. Am I right? So it becomes what?
Yes, sir.
Yeah, S by 30. So similarly, tell me for T2 and T3. S by 30 plus what is T2?
S by 60.
Very good. S by 60. Similarly for T3.
S by 120.
S by 120. Very good. So this is what you are finally getting. Now take the S outside and cancel this S.
Sir.
Yeah?
Sir, I'm sorry, sir. It's 180, sir.
Oh, sorry. S by 180. Okay. So now take the S commonly outside in the here. Okay. So S by what? S into 1 by 30 plus 1 by 60 plus 1 by 180. Cancel this S. Now, now what you can do? You can take LCM. Now take LCM and find out what is the value of average speed. Come on quickly. You can do this, ma. So what happens for 30, 60 and 180? What is the LCM? It's going to 180, right? 1 by here 180. So here 1 by 30.
Sir, 18 kilometer per hour.
Very good. 18. Your good name?
Disha, sir.
Disha. Very good. So 18 kilometers is the right answer. Is everybody getting it?
Yes, sir.
Okay. And there is another method also for this question. Okay, because it is okay. This is an easy question. You can directly substitute the average speed formula. Okay, so tell me, if two equal distance or a distance covered by two different speeds means, what is the average speed formula?
So 2v1 v2 by v1 plus v2.
Very good. 2v1 v2 by v1 plus v2. Right. Very good. And here they are given three equal distances and three different speeds. And for that there is also a formula. That is 3v1 v2 v3 divided by v1 v2, okay, plus v2 v3, okay, plus v3 v1. Here they are given three equal distances, okay, and three different speeds, and for that the average speed formula is 3v1 v2 v3 divided by v1 v2 plus v2 v3 plus v3 v1. Okay, just make a note of this formula also, or else you can just substitute this. What is v1 here? V1 is 10, v2 is 20, v3 is 60. Just substitute it and just see for yourself you're getting the same answer or not. I'll give you another 2 to 3 minutes time. Substitute in this formula. You can use calculator also, no problem, because it's kind of, the multiplication, it has 2-digit multiplication, so no problem. But just keep this formula in mind, because if you come across any like tricky questions like the one we have seen, that is they are given a distance of 200 meters, no, so for those questions, if you are coming across questions like that, but given three equal distance and three different speed, you cannot be calculating that average speed is equal to total distance by total time taken. Instead, you can employ this formula, that is 3v1 v2 v3 divided by v1 v2 plus v2 v3 plus v3 v1. So is it coming for you? Anyone? Yes, thank you, Manalini. So you can employ this formula also. Please make a note of it. Okay. Yeah, so we have completed this. Okay. Now we are going to see another topic called instantaneous velocity. Instantaneous velocity. So average velocity, what does average velocity tell us? Average velocity, it tells us how fast the object has been moving. For example, this is a time interval, let's say 0 to 20 seconds. It will say how fast the object has been moving between the time interval. Okay, but how is it different from instantaneous velocity? I'll tell you that. For example, let's say this is 10 seconds, so it's going to be 1 2 3 4 5 6 7 8, is going to be 9, and this is 10. Okay, so the average velocity will tell that the the velocity of this object between the time interval 0 to 10. Let's say the object that has come here, so the average velocity will tell the exact velocity, that is the average velocity of the object between the time interval 0 to 10 seconds. Okay, but instantaneous velocity tells the velocity of the object at different instant of time, at different instance of time. Okay, velocity of the object at different instance of time. So for example, with average velocity, you cannot determine the velocity of the object at this is all seconds. So let's say I'm going to find out the velocity here, velocity of the object at the third second. I want to know how much, what is the velocity value of that object when it has come here, when it was at the third second, at that instant. Okay, so at the third second, what is the velocity of that object? And that, my friends, the average velocity will not determine. The only thing that determines that velocity of that instant is instantaneous velocity. That's why the name instantaneous velocity. We can call it as instantaneous velocity, or we can call it as velocity at an instant. Velocity at an instant. Okay, so what is the definition of this instantaneous velocity is? Okay, it is nothing but a limiting value of the average velocity as time interval del t approaches 0. Okay, what is instantaneous velocity? Instantaneous velocity is nothing but the limiting value of the average velocity as del t approaches 0. So it is nothing but v is equal to limit del t tends to 0 del x by del t. What is this? This is nothing but average velocity. Okay, so to that average velocity we are applying limit, because del t time interval becomes 0. Okay, so what is instantaneous velocity? Instantaneous velocity is nothing but limit of the average velocity as del t approaches 0, that is the time interval approaches 0. So why the time interval approaches 0? Because while calculating uh, at an instantaneous velocity, that is velocity at an instant, for example, will take the previous example, that is 0 to 10 seconds. Okay, here I'm going to find out the velocity at the 5th second. I want to find out the velocity of the object at the 5th second. So when I do, there is no time interval involved, right? There's only instant is involved, only there is 5th second is involved. There it is not 0 to 5 seconds. You understand? If I calculate the velocity between 0 to 5 seconds, it becomes average velocity, but I'm calculating only the velocity at 5th second. So there is no time interval, it's only the instant. So the time interval del t becomes 0. So since del t becomes 0, we are applying limit. You understand the concept?
Yes, sir.
Yeah. So when we apply limit to the average velocity, what we get is we get the differential coefficient of x dx by dt. X is nothing but position. Okay, so when we apply limit to average velocity, what do we get? We get velocity as a, that is dx by dt, that is differential coefficient of x with respect to t, time. It is defined as nothing but rate of change in position, with respect to time. Can you just excuse me for a second? Yes, children. Okay, so it is nothing but rate of change in position with respect to time. Velocity is nothing but rate of change in position with respect to time, and its unit is meter per second or meter second inverse. Just a moment, ma. Just a moment. Hello, yes, ma'am. So its unit is meter per second or meter second to the power inverse. Okay. So this is what about instantaneous velocity. Do you have any doubts in this concept?
No, sir.
So you guys clear with this?
Yes,
Yes,
sir.
sir.
Okay. So we have another example sum to be taught to you, and another NEET problem is there based on this instantaneous velocity. Okay. So I think its time is up. Okay. So we'll meet on Monday. Okay. So we'll meet on Monday.
Yes, sir.
Okay, sir.
Okay. Okay.
Yes, sir.
Yes. Okay. Thank you. Thank you for watching. Okay. Thank you.
Thank you, sir.
Thank you, sir.
Thank you. Thank you. Thank you.
Thank you.
Thank you. Thank you.